I want to have a look at a library called glcore examples. You can get this in the package manager, and you should get it. It's full of really nice jitter patches using openGL, so patches that run on your graphics card. We're going to look at one particular one today called sculpt. I encourage you to just go through the examples and see what is there. This is about the workflow of taking an existing patch, just understanding how it works to a certain level, and making it audio reactive, just making it work for whatever we want to do and experiment with it. So we're going to use the sculpt patch here. And when we open it, right away we get an image here. There's steps to follow, enable, this is already happening, and we can just turn this on. Okay, so basically we have a shape, which is represented with these little dots, which is a torus, that gets modified by what they call a brush, which is this blue shape right here. Now, let me zoom out a little bit. So Option drag, so we can see the whole torus and see how it comes back. Okay, turn this on again. So just a quick overview of the patch. We have the JIT world object here, which gives us the window. We have this thing here, which gives us 3 different shapes. Now we're on the torus. We can have a duck, or what they call a clump, which is just a random blob of things. Let's stay with the torus for now. This goes into 2 buffers. We have the original shape of the torus here, and then we have a modified shape of the torus on this side. These 2 get modified by a shader, which is a text-based script that talks to the graphics card and tells it what to calculate. And this gives us a new geometry, this modified geometry of the torus modified by the brush. That goes into this object called JITGL mesh, which displays a geometry as a mesh. Now this mesh can be displayed in different ways. We're looking at it in the form of points, but this could also be triangle grid, quad grid, lines, polygons, all kind of different stuff. So you just experiment here to find something you like. Then we have this thing here, which generates gestures. This is basically just a regular max patch with random objects and lines and things like that to generate random coordinates. So if you look here, you get 2 sets of 3 numbers, which give a translation and a location of the brush. Okay, so this is just like 3D coordinates moving the brush around. Then this is the shader. This is the position. Oh yeah, we can visualize or not. We can see or hide the brush. This can be interesting because we don't want to see this, but I'm leaving it on for now just so we understand what's going on. And here, these 4 parameters are probably the most important ones for us because they can determine the kind of behavior of this thing. So let's play around with this. Let's give it more force. So if I push this up, it displaces my shape more and more because there's more force, right? It's like it's sort of hitting harder. Then we have this thing called the base mix. This will just basically bring back the shape to its original shape faster if this goes up. Let's bring the force down a little bit. We can go back to points. It jumps back very quickly to its original shape, making it somehow more rigid. If I bring this down, whoops, negative numbers are dangerous. It takes a lot more time to fold back, right? Okay, let's have this somewhere in between. The radius So the radius is basically the radius where this brush acts on. So here it's a tiny radius, as you can see, a tiny area. And as I make this bigger, it acts on a larger and larger area. And finally, the fall off. Fall off is kind of similar to radius, but it determines like how far, this force is active. So if the fall off is very small, the force is active very far. And if the fall off of this force is large, it concentrates just around the brush again. So you see with these 4 parameters, you can already get quite a bunch of interesting behaviors. Now, let's try to make this our own by importing our own model. So let's give it a bit more force. Actually, if you want to go back to the default parameters, we can just recreate this object again. So I just deleted the letter, wrote it again, and now it's recreating this object, and now we're back to the default parameters. Now, as we saw, we had the torus, we have the duck, we have a clump, and the duck is interesting because the duck is a 3D model, which if I double click here, we can see it's a glcore model calling the file duck. Now, here we're going to call our own model. We're just going to say read, and I have a model right here, DAE, which you can download. This was shared with us by the Viscom people. Now, when you load this, it doesn't update here yet because you have to bang this glcore model object first. So it actually outputs the geometry into our patch. So it just needs to receive a bang, and here we go. Now we've got it right here. Okay, now the points aren't ideal here. I'm gonna try a different shape. Oh yeah, this looks better. Let's stop this for a second. See if we can actually read what's going on here. Yeah, pretty much. Polygons, harder to read. Already had this. Actually, this is good. Let's just stay with this. So we already have the glcore handle here. We can always reset the handle. So remember, the handle is this thing here. So let's reset this, and using command drag, I can translate this, move it up and down or sideways. And using option drag, I can like drag this forward or backwards. Something like this looks good to me. And let's hide the brush now. We just want to see the shape. Yeah, I like this. Maybe it could come back a bit faster. It's a bit too fast. Yeah, something like this. And let's replace this metro with something else. So if I just bang it, every time I bang it, it will deform my shape. Okay, bang, 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 bang. And now this is perfect for us if we want to make this audio reactive. And let's give this a try. So I'm going to make some more space right here so we can add some audio stuff up here. We're going to need a sound file. I have one here by Adam TM called Riding the Void. We need a DAC just so we can hear it. Maybe a live.gain so we can adjust the level. And yeah, this is stereo. And we can play our file here. Okay. Now, what we want to do is we want to detect the onsets in this file. And I'm sure you remember the fluid. Here, let me show you in the package manager. The fluid corpus manipulation toolkit, Flucoma. In here, if you go into objects, analyze audio, you have a whole bunch of real-time audio analysis objects. We've looked at this in class already, and the one I'm going to use now is the onset feature one, which detects onsets, attacks basically. So we can just write fluid.onset slice. And let's have a look at the help file. We hear little clicks every time it detects an attack. And we're just going to copy this stuff out. So I could just use this object on its own, but I want to use this delay object because the attack detection always adds a little bit of delay. It takes a little time for the attack to be detected. It doesn't detect it right on the beat. And that's because it just needs a little bit of audio to determine if there's an attack or not. So there's a latency. And you can measure this latency with this object, getAtter latency. So here the latency is 512 samples, which is just maybe a millisecond or so. Yeah, a little bit more actually. And it delays the audio signal by the latency of the analysis. So this will just make that the movement of our brush over here will be perfectly in sync with the detection of the attack over here. So you can just go into the help patch of fluid onset slice and copy over this whole part over here. Here we go. Now we just analyze one channel, left channel. This goes in here. Here's the delayed audio signal. We're just going to do this in mono for now. And actually, we're going to listen to the delayed signal. So sorry, it's getting a little bit messy now. Here, I think we can have this horizontal actually. Where is it? Is it called layout? No. Horizontal? No. Can't find it right now. Oh, here we go. Orientation. Horizontal. Better. And we sent the mono signal to the two channels over here. And next thing, we go into the help patch here. We can have different metrics, a lot of different settings. For now, we're just gonna stay with this. What we need is the edge object, which detects the clicks coming out of here every time it detects an attack and a bang, which will show when there's an attack. Okay, so this is our attack detector here. Now let's play the file. Okay, we do get something, but it's not really working. So let's try different thresholds and a different metric. The metric is just a different algorithm of attack detection. So already, start over. If I put the threshold down, it detects a lot more attacks. If the threshold is high, a lot less. But here, this algorithm it uses to detect the attacks isn't exactly the one that works best. Let's try this one, high frequency content. With a high threshold, low threshold. Not sure this works very well. Maybe just energy. High threshold, too high. Okay, well, it's hard to see with this bang now. So let's just connect this to our patch over here. So remember, when I click bang here, it displaces my shape. So I can just connect this big bang to this little bang, and we should be able to see the attack detection in motion. Pretty good. Bring the threshold down. Too low. Let's try this again. And I'm doing all this in Max, but obviously you could make this whole patch work in Max for Live and have these parameters automated. Let's see where this goes. Pretty good. Okay, now just experiment with the parameters. Try different sections of the track.
Feet on the ground. Feet on the ground. Riding the void. Riding the void. Riding the void. Riding the void. The perfect pulse. The perfect pulse.
And maybe make this whole thing move. So digital handle auto rotate.
When our hands touched. When our hands touched. On the dance floor. On the dance floor. When our hands touched. When our hands touched.
There you go.